in our demonstration of a cart moving across a tabletop, let's suppose that the cart is here and we apply 100 newtons of force to the cart, probably by means of a hanging weight over a pulley or by pulling on the cart, and this 100 newtons doesn't change. If we knew that there was some friction acting on the cart, friction, depending on how much friction there is, many things could happen. If we, let's say, for example, that there were 25 newtons of friction acting on the cart, then the effective force, or net force, or total force, would be only 75 newtons. Okay, the cart would still accelerate because these two forces are not balanced, but the amount of effective force is reduced to only 75. We had 100 newtons of effective force, the cart would accelerate quite a bit. With 25 newtons of friction, this force will be a little bit less effective, and the effective force might, say, only be 75 newtons. Okay, we'd expect 75% of the acceleration. Friction is taking away from how hard we're able to pull on that cart and how much we're able to make things change. If there were 50 newtons of friction force on the cart, the effective force would only maybe be 50 newtons. If there were 80 newtons of friction on the cart, then maybe the effective force is 20 newtons. Each time I'm finding the effective force by subtracting 100 minus 80. In all of these cases, the forces are not balanced. We say unbalanced. And we notice that the cart accelerates. If, however, there were exactly 100 newtons of friction, then the 100 newtons of pulling force would be balanced. Okay, in the case when those forces are balanced, the cart does not necessarily not move. Okay, it may still be moving, but it would move at a constant velocity, and so we would have no acceleration, which is the same thing as saying constant velocity. So if it's moving, it would continue to move at the same steady speed. If it wasn't moving, it would continue to not move. Now, it wouldn't slow down. Okay? If the forces are exactly balanced, 100 and 100, 100 and 100, okay? If those forces are exactly balanced, the cart would not actually stop moving. Okay? It wouldn't actually get faster, but it wouldn't either get slower. It would actually continue moving at the same speed that it already has. This idea of balanced forces and unbalanced forces is another one of the big ideas we're going to talk about as we discuss Newton's laws of